we do is we create analysis projects. And the project is basically a collection of source component and sometimes also some metadata. In this case, this is a typical project, so it's called IT Landscape, and it has various components. You can see by the names which type of components I have within each. It's actually a virtual folder, and these are the components. And the way that we populate a project is, as Simon mentioned, if we use the enterprise server, which is our mainframe agent, we would just say add files from mainframe. We would get the libraries from our source management, a list of those, and we would select the members, and they would be brought using the agents directly into the project. If we don't have the given installation the agents, then the sources would need to be FTP'd over to our server side and then added to the project. So this is the first step. I decide what to put within my project. Usually a project represents what we call or we map it to an application. You can have a lot of projects and of various types. So if you're working on a subset of components, like a subset of an application, you can also create a project to represent that subset. So it doesn't have to be always a project maps to a full application, but usually the basic project that we put in place are ones that map applications. And also we usually have a project that map an application in production state. It means the project contains source code from production and usually another one from development. Once I have this project set up, we have a step which is called the build, and the build is our own compilers running on the Windows side, processing the source codes and producing, instead of object code, producing data into the relational database. And once this is done, we can schedule a periodic update. As Simon mentioned, again through the agents, we check if something changed. So usually it's scheduled nightly, and whenever you come in the morning, you know that it's up to date. Once you have this build in place, you can start to do the analysis. And whatever I'm going to show, the rest of the demo here is based on information that was collected at build time. So I'm going to start with the dashboard. The dashboard is information. It's high-level information on a project or application level. So although EasySource collects information on a very low level, so up to a program level, statement, variable level, here what we do is we aggregate the information on an application level, and what we do is we collect it over time and we trend it over time. And this is used mainly by management level. So let's look at how we see the information here. So first I'm going to choose the applications which I want to see information for. So I have two applications configured in this dashboard, and each of them have a development version and a production version. And I'm going to choose a resolution. So I'm going to look at the weekly resolution. You can set a time period, so it can be up to the present or any given time frame in the past. And finally, I'm going to choose a category, for example, inventory. Let's look at the number of artifacts. Now, what this shows me is the current inventory state of my applications. This is the top right. So I have claims management in development, has over 38,000 artifacts, and in production it has 33 artifacts, 33,000. The top part shows you the current state, or the last according to the date you've selected, but usually it's said to be the present. So this is what's currently happening in your applications according to inventory. The bottom part shows you how your inventory changed over time for each application. And then you can see changes like development phases and move to production phases and so on. And inventory can be represented by other metrics or measures. Number of artifacts, lines of code, number of statements. So each category has various ways to look at information in the category.
Hi, it's Jeremy. I have a quick question.
Sure.
You said that the builds can run every night through a scheduled process. Does that also bring over the latest code from source control?
Yes. If you use the agents, the mainframe agent, the Windows side requests an update, and only the changes in, let's say, Endeavor or ChangeMan, or even if it's PDS library, only the changes are brought over. Then the compilers go over only the deltas, and the repository is updated.
Okay. What if you didn't want it? Like, I mean, is there a way to control what comes over and what doesn't?
Yes, there are two. You can decide for a project whether it's going to update against the mainframe or not, or whether it's going to build the changes or not build the changes. So this is configurable. Or
Okay.
You can decide not to modify at all a given project. Let's say you want to keep a project showing you a snapshot of 2 months ago. You don't want to touch it. You can just leave it as it is.
Okay, thanks.
Okay, so similar things like complexity. What's the complexity state of my applications? How did I change the complexity, or the complexity changed over time? Let's say I want to make sure that I'm doing changes and I don't want the average complexity to go up, for example. I can monitor this and see those changes. Again, there are various ways to measure complexity and various ways to measure quality changes. For example, dead code would mean the percentage of dead code within my applications. So you can see one application has quite a lot of dead code. It's, I would say, more than the others, definitely. So 6% and more dead code compared to the others. There's also a way to categorize, so you can set up the percentage to say what you consider as okay, which would be the green area, then the yellow and the red. So you can easily see if something goes into the yellow area, for example. And I didn't get any change in the dead code, so at least that's not changing for the worse. If I do make the effort of reducing the dead code, I can monitor here to see if actually it gets reduced. And also, yes.
It's George. One question I want to ask you: what is your definition of the dead code? What's the difference between the dead code and redundant code?
Okay. So we can get different types of dead code analysis from our repository. In this case, these are paragraphs or procedures or subroutines within the code that they have no control flow that leads to them. So there's no way the control flow can get to these paragraph or procedures. There's also performance information, like and you can query the repository if you collect SMF information to say, show me programs that weren't executed for this amount of time, or if you're using a scheduler, then show me jobs that are not in my CA7 schedules. Right, so there's other ways. It's not the only way, but specifically here is this is what is called dead code here.
Thank you.
Okay, performance. This is SMF based information where we get CPU usage, execution frequency, IO count, and also failure of jobs. So you can monitor. I mean, it's not. You can see over time whether your let's say daily number of failed job increases. Okay, so it's not a monitor to see that something just happened to a job, but it's more of seeing the big picture over time and seeing whether situation gets worse. As Simon mentioned, we have external information coming in, like actually anything. There is a generic interface. You can put in any information that you have for your applications, like faults, number of faults from, let's say, bug tracking system or ticketing system, cost information. And this allows you to see the changes over time. But what it also allows you is to try and correlate between any type of measurement here. So, for example, if I discover, for example, that the cost of my development, or let's say the number of issues went up in the last few months, and we think that it might be related to changes that we've done in the code, and the code now perhaps is more complex, and it takes us more time, or there are more issues coming out, we can configure the dashboard to put one measurement against the other. And then you can see whether they correlate, so whether they go together, they go up together, or they go down together. Basically try to see if there is a relationship between those. So if, for example, I discover a relationship between the complexity going up and the number of issues, maybe it's worthwhile for me to reduce the complexity and also monitor to see whether the number of issues, there are no number of new issues coming up, or it's not, is dropping as well. Or maybe the cost. Maybe it's taking me a lot of time to do some minor changes. So you can just put cost versus changes, complexity versus cost, anything, just to see if they correlate.